Mid-career researcher award winner Dr. Bao joins us to discuss her cutting-edge research. Dr. Bao, congratulations on having been named the 2021 MRS Mid-Career Researcher Award winner.
Thank you, Autria.
Your award citation reads, "For pioneering contributions and conceptual developments to organic electronics and skin-inspired electronics." Tell us a little bit about what organic and skin-inspired electronics are, and then about your particular work in this field.
Our vision for the future of electronics is they're going to be invisible, biocompatible, and imperceptible. So we imagine that using a type of material that will mimic the skin properties will enable us to achieve that goal. So my group has been working with understanding the design of organic electronic materials for many years. But about 15 years ago, we started thinking that these organic materials are perfect to realize all the skin-like properties such as stretchability, biodegradability, as well as self-healing properties. So we started the journey to understand how we design these new generation of electronic materials from molecular level. And over the past decade, we have already come up with a range of materials and design rules for conductors, semiconductors, as well as dielectric materials, and incorporating the skin-like properties without compromising their electronic properties.
What was it about this particular area of materials research that drew you into this particular field?
Well, initially, as I mentioned, I have been working with organic electronics for a number of years. And then I learned about this need for patient with who wears a prosthetic hand, and they don't have the sense of touch, and that makes it very difficult for such patient to be able to live a normal life. And I thought flexible electronics potentially can do something to help such patient. So we started from trying to mimic the sense of touch using flexible electronic materials. But then we realized that we're basically mimicking the functions of human skin. And why don't we make the materials not just flexible, but also incorporate other skin-like properties? Then our current electronics are rigid and brittle because the materials making them are rigid and brittle. But if we turn these materials into skin-like materials, then the electronics we use are going to be completely different, and it can potentially change how humans interact with electronics and how we interact with each other.
What are some of the other applications that either have come from or may come from skin-inspired electronics?
So in addition to prosthetic hand to add the sense of touch, a natural extension to that is to add sensors to robotic hands for better grasping and for robots to be able to work together with human more efficiently and more safely. And then going beyond that, wearable electronics or putting sensors and electronics onto our body to allow us to be able to really understand our own health and monitor our health is the next application. In fact, we spun off a company that is currently developing a product for premature babies to monitor their blood pressure non-invasively. And then moving from outside the body to inside the body, implantable electronics is the further future. With skin-like materials, they're soft and compatible compatible with our soft tissue. They can be implanted without damaging the organs. So that could allow new possibilities. And finally, there are also branches of applications that spin off from the skin-like electronic materials that we did not envision earlier, but we discovered, for example, using such materials, we can make skin-like coatings for lithium-ion batteries or lithium metal electrodes, and to make them more stable and more reliable for future batteries.
And you also founded the Stanford Wearable Electronics Initiative, aka eWear, back in 2016. What are some of the goals or outcomes from that group?
When our research has reached a stage where we have some materials and some devices that we know they have great potential for applications in medical devices, in robotics, and they will require the researchers, not only from my field in materials research, but also researchers in other fields to work together in order to further the direction of skin-inspired electronics. So I felt the need to have such a initiative to allow researchers, students, and faculty from Stanford to work together, and also allow us to have a entity so that the external companies and researchers, they also know where to go if they wanted to work with us. So eWear has been serving this role to both connect researchers within Stanford, as well as allowing us to interact with many others in the world.
Dr. Bao, again, congratulations, and thank you for your time today.
Oh, thank you. It's my pleasure.